This video is going to walk through some of the problems, factoring problems, when the lead coefficient is not positive 1. So notice that when you begin factoring, you should always have the quadratic or the polynomial arranged in standard form, lined up in order by exponent. And here notice that the lead coefficient is not positive 1. The lead coefficient is the coefficient on the quadratic term, or the term of highest power. So to factor something like this, draw the big X, and the top of the big X gets the product of A times C. So in this problem, that would be 2 times 2, which is 4, and the bottom of the big X gets the coefficient on the linear term, or 5. You're looking for factors of 4 that sum to 5, so that's going to be 4 and 1. Rewrite the original trinomial and expand it so that it now has 4 terms. So 2x squared, and instead of writing 5x, I'm going to express 5x as 4x plus x. And now you're going to introduce grouping symbols for your factor by grouping skill. So group the first two together, group the second two together. Look for a greatest common factor in the first pairing. That would be 2x. So I reverse distribute 2x away from both. You can think of dividing 2x squared by 2x, and you would have 1x left over. Think of dividing 4x by the 2x, and you would have 2 left over. So the whole point in this step is to create a matching binomial with x plus 2. So in this particular problem, I already have x plus 2, so I'm only going to need to reverse distribute out a 1. So I've now created the matching binomials, and it's time to bring these together to present my final factors. So I copy the binomial x plus 2 one time, and then the two GCFs that came out, they come together to create their own little binomial. So my final factored form of the original quadratic would be the following pair of binomials. If I were to multiply these out, I would end up right back where I started. I'm skipping down to number 4. So notice that it's arranged in standard form. There's no GCF to reverse distribute out. It's not a pattern. So I'm going to draw the big X. The top of the big X gets the product of the lead coefficient and the constant. So here that's going to be 6. And the bottom of the big X gets the coefficient on the linear term. So that's going to be negative 7. I'm looking for factors of positive 6 that sum to negative 7. 6 is positive, and the 7 is negative. So this is my cue that both factors are going to be negative. Negative 6 times negative 1 gives me positive 6, and when I add these two numbers together, I get negative 7. So I recopy the original trinomial, and I expand negative 7x as negative 6 minus x, and then I introduce the grouping symbols for factor by grouping. 3x is the common GCF factor in the first binomial pairing, so I reverse distribute that out, leaving me with x minus 2. And in the second binomial pairing, I need positive x and negative 2, so I'm going to reverse distribute out a 1, and that's going to leave me with positive x and negative 2, so I just wrote plus negative. So now my first binomial factor is going to be x minus 2 or x plus negative 2, meaning the same thing. And then the binomial partner, I bring together the two GCFs that were removed. They come together to create their own binomial factor. I'm going to move to problem number 6 next. So notice that, once again, I'm going to run through my mental factoring checklist. It's arranged in standard form. There's no GCF. It is not a pattern. So I'm going to draw the big X. The top of the big X gets the product of 9 and negative 8. That's negative 72. And the bottom of the big X gets the coefficient on the linear term. Since the top product is negative, that's my cue that one factor is positive and one factor is negative. So here I'm going to go with positive 12 and negative 6. I'm going to rewrite the original trinomial with 4 terms. Introduce my grouping symbols for factor by grouping. Reverse distribute out a 3x, leaving me with 3x plus 4. In my second pairing, I need to reverse the sign on both, and they share a 2. So I'm going to reverse distribute out a negative 2, so that what's left behind is positive 3x and positive 4. I've now created the two binomial factors that I'm looking for, and the GCFs come together to create the other binomial pairing. And the last problem I've chosen for the video is number 8. So as always, it's arranged in standard form. There's no greatest common factor. This is not a pattern. So I move to the big X. The top of the big X gets negative 48, and the bottom of the big X gets a positive 2. I'm looking for factors of 48 that differ by 2, and that's going to be negative 8 and positive 6. And I recopy the original and introduce my grouping symbols. And in the first pairing, there's no numerical GCF. They only share an X. So I reverse distribute the X out. And then in the second pairing, I'm going to remove a positive 2. And then I'm finally done. Bring my factors together. I have x plus 2 and 3x minus 8.